Any questions before we proceed? Yes.
The last question. Why do we need biconditional?
طيب, in the last quiz, why do we need biconditional? The reason why we need biconditional is that if if you just say x not equal implies visited, if x is equal false, صح? If it was equal to Maldives, this is false, right? طيب, false implies anything is true, صح? It could be false implies the true, انه x visited Maldives. He visited all countries. And in fact, one of you corrected me. I think his name is Muhammad Sharbini. Yeah. That's why it should be if and only if, مش implied. Okay. طيب, that's good. Okay, so let's go back to sequences and summations. طيب, now how do we evaluate summations? Well, first of all, let's look at the summation on the right, which is kind of easy. What is the summation on the right? شو رايكم يا شباب? Yes, this is 2 plus 4 plus 6. This is 2 plus 4 plus 6, right? طيب. Okay. So if you want to try to do it like the one on the right, there are I times j. What does that mean? For I equal 1, you need to multiply it first by 1, and then you multiply it by 2, and then you multiply it by 3 for every value of j, صح? Because this is a nested summation. And similarly, you need to do that for 2, for 3, for 4. Good luck. Okay, try it at home. If you want to do it this way, try it at home. What is the best way of solving this question? Yes. Because I does not depend on j. I can take it outside, صح? I can, طبعا not all the way outside. So basically, this is sigma I from I equal 1 to 4, sigma j from j equal 1 to 3. Okay. So now what I can do is, now I can evaluate the summation, and then it will be a value, which is a constant in this case. I will take it outside, and then I will continue. Okay. So using the formulas, what is sigma j from j equal 1 to 3? اللي هي 3 times 4 plus over 2, صح? So this is equal to sigma I from I equal 1 to 4 multiplied by 3 times 4 divided by 2. What is this equal to? This is 6, صح? So this is equal to 6 sigma I from I equal 1 to 4. And what is 6 sigma I from I equal 1 to 4? 6 multiplied by sigma I from I equal 1 to 4, 4 times 5 divided by 2. ايش بيساوي؟ Okay. So this is how we deal with double summations. Okay. We first try to evaluate the innermost summation. In this case, this is the innermost summation. Or in fact, this is the innermost summation. And then we move to the outermost summations. Yes. You don't need to memorize them, as I said last time. It's better to memorize them, but we will give them to you. Okay. Right. Now, how do we find the summation? Sigma k squared from k equal 50 to 100. Now, there are two ways to solve this. One way is a little bit hard, which is basically doing an index change. Okay, which is doing an index change. So now, instead of because here I cannot apply the rules, صح? K is starting from when? K is starting from 50, and I want to start from 1. So if I want to start from 1, I need to introduce another variable J, which is equal to K minus 49, okay? And then write K in terms of J and then evaluate. I'll leave that for you. Okay, I will leave this method. I will leave it for you. What is the best method to solve this question? How can I solve this question in the fastest way of solving this question? How? I can't use the formula in this. I cannot use the formula. So how can I use the formula? Sigma K square from K equal 1 to 100 minus sigma K square from K equal ايش to ايش؟ أيوة 1 to 49. If you make it from 1 to 50, you are removing the value at K equal 50, صح? So we need to go from 1 to 49. From 1 to 49. Now, can I apply the rules on these two summations? Yes, now it's very easy to apply the rules on these two summations. This is equal to what? Well, this is equal to 100 times 101 times 201. Correct me if I make a mistake. Divided by 6, صح? N times n plus 1 times 2n plus 1 divided by 6 minus 49 multiplied by 50 multiplied by 99, صح? Divided by. شو رايكم يا شباب؟ Any question? طيب. This summation, does it look similar to any of the summations that you see on the left, on the right? The one before the last. Oh, forget about the last two. The last two, actually, this is the solution, right? What I meant was from the first four, 1, 2, 3, 4, from the first 4 summations. It looks similar to the first, right? It looks similar to the first. A is equal to 1. And the only difference is that this summation is until n equal infinity. This summation is until n. Huh? So how can I get this summation, from this? All what you need to do is use formula 1 from k equal 1 to n, from k equals 0 to n, I mean, from k equals 0 to n. Use formula 1 from k equals 0 to n. Number 2, shall I use my it seems this is the last time I'm going to record in this section. There is always a problem in the let me see if this makes a better اوكي معلش يا شباب. ضيعت على الاخر. اوكي طيب. So I will leave this for you as an exercise, okay? And it's actually very straightforward. طيب. Now look at this, sigma x to the power n from n equals 0 to infinity. We know that this is going to be equal to 1 over 1 minus x. And let's look at this. Can anybody find any relationship between this summation and sigma x to the power n as n goes to infinity? From 0 to infinity. ايش؟ علي صوتك. The derivative, it's the derivative, صح? What's the derivative of x to the power n as n of x to the power n? What's the derivative of x to the power n? n x to the power n minus 1. طب مش هذا هو نفسه؟ kx to the power k minus 1. So in order to find sigma kx to the power k minus 1 from k equal 1, why is k 1 not 0? Because when k equals 0, 0 multiplied by anything is 0, صح? So that's why it's k equal 1. So in order to find this, you just need to find the derivative of the value of the summation. طبعا the value of the summation is 1 over 1 minus x. Okay, so just find the, so just basically take the derivative of اللي هي sigma x to the power n from n equals 0 to infinity, which is equal to 1 over 1 minus x. Take the derivative of both sides. You will get the answer. Forget about this. Well, I'm gonna do this for you as an exercise. We took a lot of sequences, yani, so I'm not gonna do it again. So let us now move to cardinality of sets. Let us move to cardinality of sets. Now, sets A and B have the same cardinality by definition. Okay, they have the same cardinality if there is a one-to-one correspondence between A and B. ايش يعني one-to-one correspondence؟ ها؟ لا. ايش يعني one-to-one correspondence؟ AI equals BI. One-to-one correspondence. ايش يعني one-to-one correspondence؟ It's a one-to-one and onto. If you define a function that is one-to-one and onto from A to B, then this is called a one-to-one correspondence. A one-to-one correspondence. Okay, a one-to-one correspondence. طيب. And this applies in general for any set, for any two sets A and B. Okay. طيب. Now let's come to definition of a countable set. A set that is either finite or has the same cardinality as the set of positive integers, اللي هي Z plus. Any set that is either finite or have the cardinality, have the same cardinality as the set of positive integers is called countable. It's called countable. A set that is not countable is called uncountable. A set that is not countable is called uncountable. When an infinite set S is countable, we denote it by aleph null. Okay, aleph null, where aleph is the first letter of the Hebrew alphabet. Okay, and we write it as the cardinality of S is aleph null or aleph 0, but it's actually it's said aleph null. So this is the definition of countable. Okay, طيب. So now the question is, what do we need to do to find whether a set is countable or not? What do I need to attempt to do? Yes. Find a one-to-one correspondence between Z plus and the set. Find the one-to-one correspondence between Z plus and the set. If you can find such correspondence, you're fine, you're done. If not, then, well, we will see actually an example of an uncountable set, and we will prove it. Okay, we will see an example of an uncountable set, and we will prove it. So let's start with the first one. Show that the set of odd positive integers is countable. Odd بس. What's the set relationship between odd positive integers and positive integers? ايش الست relationship؟ subset وproper ولا ما هي proper؟ proper. The odd positive integers is a proper subset of, yet they have the same cardinality. طبعا لو كنا في الفاينايت this will never happen صح؟ انه يكونوا two sets one of them is a proper subset of the other and they have the same cardinality. لكن that's a problem with infinity. In infinity things go crazy. Okay, so Z plus has the same cardinality as odd positive integers. طيب شو رايكم؟ So let's list Z plus اللي هي مثلا 1 2 3 4 5, and can anybody define a function that will take 1 to 1, 2 to 3, 3 to 5, 4 to 7, 5 to 9, and so on and so forth? F of n equal 2n minus 1. F of n equal to n minus 1. Of course, you need to prove that this is a one-to-one correspondence, but it's very straightforward. The proof is very straightforward, just like what you learned in section 3. Okay, but this is a one-to-one correspondence. واضح؟ طيب, not only that, show that the set of all integers is countable. Show that the set of all integers is countable. So now, what I need to do is I need to find a one-to-one correspondence from the set of positive integers 1, 2, 3, 4, 5, 6 to all integers. To all integers. Right. So what is that function? Well, let me define the following function for you, and let's see how things go. Okay. Let f of n be equal to معلش خليني ابعدها شوي. Let f of n be equal to n minus 1 over 2 if n is odd, minus n over 2 if n is even. Let me ask the first question. In n minus 1 over 2, do we have any guarantees that this is always integer? In this case, I mean. It's always integer. ليش؟ لأنه it's odd. It's odd. n minus 1 over 2 is always an integer. Similarly, اللي تحت n over 2 is always an integer. ليش؟ لأنه n إيش ماله؟ Even. So negative n over 2 is always an integer. Okay. طيب. So let's see what does that function do. So this function f of n equal n minus 1 over 2 will apply to numbers like 1, 3, 5, 7, صح? So what is f of 1? f of 1 0, صح? Well, f of 3 is 1. Well, f of 5 2. ليش minus 2? f of 5 is 2. f of 7 3. And I will continue, and so on and so forth. اوكي طيب والاف اوف 2 والاف اوف 4 f of 5 f of 6 and so on and so forth, so on and so forth. Now, are you convinced that this function is a one-to-one correspondence from z plus to z? Tara, if you give me any element in z, I can find, you know, which element map to it. صح ولا لا? If it is positive, I know it's an odd number. If it is negative, I know it's an even number. And I can get it. And I can get it. See, that's why another way of showing that that a set is countable is that if you can list its elements, all its elements. يعني مثلا z ايش ال z plus ايش all its elements, you know, 1 2 3 4 until infinity, صح؟ ال odd 1 3 5 7 until infinity. طيب z, look at this, isn't this a listing of the elements of z اللي هي you start from 0 بعدين minus 1 1 minus 2 2 minus 3 3 minus 4 4 minus 5 5 minus 6 6, صح؟ So it's basically a sequence. It's as if, so that's why when I say if you can list the elements of the set as a sequence, you know, A1 A2 A3 A4, this is a one-to-one correspondence, صح؟ مش السيكونس هي one-to-one correspondence او السيكونس ايش الدومين تبع السيكونس اللي هي z plus 1 2 3 4 لغايه الانفينيتي، صح؟ ف if you can list all the elements of the other set as a sequence, that set is countable definitely. فلذلك الزي هنا ايش؟ countable. Z countable. طيب not only that, but even a set of positive rational numbers. شو رايكم؟ Set of positive rational numbers. This is also countable. And we are not going to be as lucky, you know, to find a function like this for a set of positive rational numbers. No, this time we are going to just be content with being able to list all the rational numbers. طبعا كيف شكل الراشونال numbers؟ اللي هو P over Q، صح؟ اللي هو P over Q. طيب نعم. Well, in this case, يعني انت you want to prove that minus 1 0 1 2 is countable. خلاص ال1 وديها للماينس 1 وال2 وديها لل0 وال3 وديها لل1 وهكذا. Okay. طيب. So how do I show that the set of positive rational numbers is countable? This is how what I'm going to do. What I'm going to do is the following. I'm going to write the elements in such a way. Okay. So for example, I'm going to do 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1, 6 over 1. The next row, 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2, and so on. Okay? Next one, 1 over 3, 2 over 3, 3 over 3, 4 over 3, 5 over 3, 6 over 3, and so on and so forth. 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, and so on and so forth, and so on and so forth. Okay? طيب. Now let's see how can I do this mapping. Okay? Look at this. I will scan the elements in this way. So basically in this direction. Okay, I will scan the elements diagonally like this. Okay, right. So basically the first element that I will encounter is 1 over 1, صح? Right. So this element, I will map 1 to this element. 1 is mapped to 1. Right. Next, where do I go to? I go here, صح? طيب 2. Did I see 2 before? So I will map 2 to 2. Right. Did I see 1/2 before? I'll map 3 to 1/2. Did I see 3 before? So I'll map 4 to 3. Did I see 2 over 2 before? Yes, I saw it. So I will skip it. Because 2 over 2 اللي هي نفسها 1 over 1 صح؟ It has already been mapped. طيب, what about 1 over 3? I will map 5 to 1 over 3. I will map 4. I will map 6 to 4. طيب, will 3 over 2? 7 will be mapped to 3 over 2. 8 will be mapped to 2 over 3, and so on and so forth. And so on and so forth. طيب, if let me ask you, if I list the elements of rational numbers like this, am I going to miss any rational number? But I will not. ليش؟ أعطيني أي rational number, P over Q. What am I going to find P over Q? In row, P over Q will be found in row Q, صح? Column P. Row Q, column P. Okay? So, did I convince you that there is a listing from a set of rational numbers, positive rational numbers, from the set of positive integers to the set of positive rational numbers? This is a listing. This is a one-to-one correspondence. This is a sequence. I will not miss a single rational number, and I have ordered all rational numbers. I was able to order all the rational numbers as a sequence. واضح يا شباب? Yes. Well, we are mapping here to positive rational numbers. For 0, you can start from 0, then continue. يعني ممكن نحط الزيرو هنا. We can put, for example, the 0 here, and then you move like this. Here, the most important thing, I want to list all the elements of my set. If I was able to list all the elements as a sequence, the first element, second element, third element, basically we will be done. It turns out, if we try to do the same thing on rational numbers, on real numbers, it will not work. And in fact, inshallah, day after tomorrow, we will show that the set of real numbers is not countable or is uncountable. Okay? واضح يا شباب؟ طيب. Yes, because I listed it. I listed as I can list all the elements of the positive rational numbers, as a sequence.
Makes sense, but don't you have to define like a bijection?
Well, it is a bijection. No, you don't have to have an explicit function. You don't have to have an explicit function. Okay, so you're ready for the quiz? So let me close this.